Okay, so topic for today, trig identities. So hit pause, get the heading and lesson objective down. When you're ready, hit play again. Okay, so we're going to use trig today to investigate these identities. We're going to investigate two identities, very useful. So to do that, we're going to look at this unit circle, which we've placed with the center at the origin. So I can say it's a unit circle, so I can sketch its radius here. It's got a radius of 1 because it's a unit circle. And I'm just going to drop a line, perpendicular line there to the x-axis. So I've got myself a triangle. Now my triangle, my angle here is theta. Now when theta is under consideration and I've got a right angle triangle, the longest side is the hypotenuse. The side opposite the angle under consideration is the opposite side, and the side next to the angle under consideration is the adjacent side. So I'm going to use my trig then to work out these identities. In the first instance, trig means I'm going to need help with SOHCAHTOA. So I'm going to use that, I'm going to apply that, and I'm going to work out what the opposite and adjacent sides are of this hypotenuse, which has a radius of 1. Now, if I want to work out the opposite, and I know the hypotenuse, I can use sine. Sine of theta, in this case, I'm going to look at the opposite over hypotenuse, O over H. So that's going to be O over H. Now, we don't know the opposite, but we do know the hypotenuse. So sine theta, we substitute for the hypotenuse, is equal to O over 1. It's our unit circle. So that implies then that O is equal to sine theta. So I'm going to write that in there. This side is sine theta. I'm going to look at the adjacent. I know the hypotenuse, so I can use cos theta. Cos theta is equal to the adjacent over the hypotenuse, so A over H. Hypotenuse, the radius of our unit circle, is 1. So cos theta is equal to A over 1, which means that A equals cos theta. So I'm going to write that in here. Now I've got a right angle triangle. I know a few things about right angle triangle. One of the things I do know about right angle triangles is Pythagoras. So by Pythagoras, a squared plus b squared is equal to c squared, where c is the hypotenuse. So I'm going to apply that here, and I'm going to say sine squared theta plus cos squared theta is equal to h squared, or 1 squared, which is 1. And that's our first identity. Sine squared theta plus cos squared theta equals 1. So you can write that down. Hit pause, copy that down. When you're ready, hit play again. And we're going to look at that second identity. Okay, to look at the second identity, I'm just going to change my pen. Let's use a blue pen. Let's look at tan theta. Tan theta is equal to opposite over adjacent, O over H. And I'm going to substitute for O over A rather, sorry, O over A. So I'm going to substitute for O and A. So tan theta. Opposite side is sine theta, and the adjacent side is cos theta. And that's our second identity. So hit pause, copy those down, and we'll have a go at using these two identities we've now introduced. Okay, so let's have a look at this this example here. tells us that sine squared 3 theta plus cos squared 3 theta. How do we simplify that? Now I know that sine squared theta plus cos squared theta equals 1. As long as these angles are the same, the expression remains the same. So this implies then that sine squared 3 theta plus cos squared 3 theta is equal to 1 as well. And that's it. That's all you've got to do on that one. Hit pause, write the example down. When you're ready, hit play again. Okay, let's have a look at another example. This time, we've got to simplify 5 minus 5 sine squared theta. So let's write that here. Simplify 5 minus 5 sine squared theta. So I'm going to factorize that first. So that's going to be equal to 5 is common on both sides. 5 and then it's 1 minus sine squared theta. Now then, something I do know is cos squared theta plus sine squared theta equals 1. So let's just do some workings. Let's do it down here. Sine squared theta plus cos squared theta equals 1. So I've got here 1 minus sine squared theta. So if I leave the cos theta on the left hand side and I take my sine theta, which is positive here, take it over to the right hand side, that means cos squared theta is equal to 1 minus sine squared theta, which is what I have in that expression, 1 minus sine squared theta. So I can say, if I go back to red, that's equal to 5 times 1 minus sine squared theta is cos squared theta. And it's simplified. Job done. One thing to note is that cos squared theta equals 1 minus sine squared. By the same token, if I had written cos squared theta equals 1, if I'd taken my cos squared over the other side, I'd have been left with sine squared theta on this side, which is equal to 1 minus cos squared theta. So they're not new identities, they're just a reworking of the original identity. Okay, good. So hit pause, copy the example down. When you're ready, hit play again. We'll look at another one. Okay, so we've got to simplify this expression. Sine 2 theta over 1 minus sine squared 2 theta. So we've got to simplify that. Now, I'm just going to write my other expressions down from before, because I wrote down cos squared theta, sine squared plus cos squared equals 1. Cos squared theta equals 1 minus sine squared theta, and sine squared theta equals 1 minus cos squared theta. Okay. So, looking at this expression here, sine of 2 theta all over the square root of 1 minus sine squared theta, sine squared 2 theta even. Just rub that out. Okay. Sine squared 2 theta. That's equal to, I'm going to leave my sine 2 theta alone for now. And I'm going to divide it by the square root of 1 minus sine squared 2 theta. Well, that's going to be cos squared 2 theta. I've got to find the square root of cos squared 2 theta, because that's equal to 1 minus sine squared from there. Now the square root of cos squared is going to be just cos. Now I know that tan theta equals sine theta over cos theta. It's my other identity, sine over cos. So the only difference is that it's 2 theta. Tan 2 theta. Job done. That's a tan there. Hit pause. Copy the example down. When you're ready, hit play again. We'll look at another one. So in this example, we have a proof. We want to prove that cos to the power of 4 theta minus sin to the power of 4 theta over cos squared theta is the equivalent of 1 minus tan squared theta. Okay, so let's write that over here and have a go. Well, with a proof, you can start with either the left-hand side or the right-hand side. What we're going to do is taking the left-hand side, so we're going to use the left-hand side. Take the LHS, left-hand side, so let's write that cos to the power of 4 theta minus sine to the power of 4 theta, all divided by cos squared theta. That's equal to, if I look at the top here, it's not so easy to identify, but that is dots, difference of 2 squares. So I can factorize that as cos squared theta plus sine squared theta multiplied by cos squared theta minus sine squared theta, all divided by cos squared theta. So we can factorize the top because we've got dots, and remember, because we've got a positive and a negative, it cancels out the middle term, which is why we end up with cos to the power of 4 minus sine to the power of 4. Right, I know something about cos squared theta plus sine squared is equal to 1. So that's just 1 times that, so that leaves me with cos squared theta minus sine squared theta. I need to complete my thetas actually. Okay, that's a bit better. All divided by cos squared theta. In order to simplify, I'm going to separate the fractions. So I've got cos squared theta divided by cos squared theta minus sine squared theta over cos squared theta. Now cos divided by cos, that's just going to be 1, minus sine over cos, we've established that to be tan. So it will be 1 minus tan squared theta. Job done. That's exactly what we needed to prove. So hit pause, copy the example down. When you're ready, hit play again. We'll look at one more. Okay, let's have a look at this question here. It says, given that cos theta is minus 3 over 5 and theta is reflex, find the value of sine theta. Now reflex means, I'm trying to recall it from my GCSE days. Reflex means greater than 180, but less than 360. In fact, I could write that a lot better than that. So it's going to lie in that range. Okay, now I've got my identity, which I always fall back to. Sine squared theta plus cos squared theta is equal to 1. I want to find sine theta, so if I leave sine theta on the left hand side, sine squared theta, I'm going to take my positive cos theta over to the right hand side, so it becomes negative, equals 1 minus cos squared theta. I know cos squared theta is minus 3 over 5, so I'm going to sub that in. 1 minus 3 over 5 squared, so that's equal to 1 minus times minus gives me plus, so that's going to be, if I square that, I get 9 over 25. So it's 1 minus 9 over 25, which is well, let's do it properly then. 25 over 25 minus 9 over 25, which leaves me with 16 over 25. So that's sine squared theta. That means sine theta is equal to the square root of that. I'm not completing my thetas again. Dreadful habit. So that's going to be the plus or minus the square root of 16 over 25, which is equal to plus or minus 4 over 5. So I've got two answers. I've got plus 4 over 5 or minus 4 over 5. Which one is it? Now I know that sine theta is, well, theta is reflex. So it's got to be bigger than 180 and less than 360. So if I sketch my curve like so, I know it's got to lie in this range here, anywhere from 180 to 360. So if I went for positive 4 over 5 or 0.8, that would be over here. That's 0.8. And it intersects the curve here and here. So that's no good to me. But negative 4 over 5, it's going to be down here somewhere. Minus 0.8. And when I draw my curve, my line rather, fantastic. It intersects the curve there and there. Okay, so I think my answer is going to be there. But for these purposes, I can say sine theta is equal to minus 4 over 5, because positive is too small, it's less than 180. Okay, so what I want you to do now is, as usual, hit pause, make some notes. When you're ready, hit play again. Okay, so look at this example here. It says, given that sine theta is 2/5 and theta is obtuse, find the value of cos theta. Now I'm trying to recall what obtuse means from back in the GCSE days. Obtuse means it's bigger than 90 and it's less than 180. So it's going to fall within that range. So back to my identity. Sine squared theta plus cos squared theta is equal to 1. That means cos squared theta is equal to, if I float my sine squared theta over the equal sign, it becomes minus. So 1 minus sine squared theta. I can now sub for sine. So that's going to be 1 minus 2 over 5 squared. So that's going to be equal to 1 minus 4 over 25. Now, I want to subtract, so 1 is equal to 25 over 25 minus 4 over 25, which leaves me with 21 over 25. But that's cos squared theta. I want cos theta. So that's going to be plus or minus the square root of 21 over 25. That's the same thing as plus or minus the square root of 21 over 5, because the square root of 20 over 5 is 5. Which one is it? Is it the positive or the negative value? Because I've got 2 here. Well, we sketched a curve. That's 90, that's 180. So it's got to fall within that range. 270 and 360. So it's got to fall within this range here. From 90 to 180, and somewhere in there. Now if I look at positive value of 20, square root of 21 over 5, square root of 21 is going to be between 4 and 5, so it's quite high, somewhere over there. If I sketch it, it doesn't work for me. It hits the curve before 90 and then after 270, so it can't be square root of 21 over 5, not a positive one. If I look at the negative value of square root of 21 over 5, and I draw a line from there across, It's much more useful. It falls exactly where I want it to, between 90 and 180. So that's got to be my answer. So therefore, cos theta is equal to minus the square root of 21 over 5. So what I want you to do now is to hit pause, copy the example, copy the diagram, very important. And when you're ready, hit play again. And we'll look at one more example. One more. Right, as I said, the last example. So here, given that P equals 3 cos theta and Q equals 2 sin theta, show that 4P squared plus 9Q squared equals 36. Okay, so it's a proof again. So what we're going to do with the proof then is, let's have a look at what they've given us. They said P is equal to 3 cos theta. Well, that implies to me that cos theta is equal to, let's get it on its own, P over 3. And they say that Q is equal to 2 sin theta. I'm going to get the sin theta on its own, and that's equal to Q over 2. Okay, so I've got a value for cos theta and sin theta, and I've got an identity that says sin squared theta plus cos squared theta is equal to 1. Sin theta is Q over 2. Well, let's substitute here. Q over 2 squared plus cos theta is P over 3. So P over 3, substitute there, squared is equal to 1. Expand and simplify. So that's going to be Q squared over 4 plus P squared over 9 is equal to 1. I need a common denominator. What do 4 and 9 both go into? Very handy, 36. To get to 36 is 4 times 9, so I've got to multiply the numerator. That's 9Q squared. That's looking promising. And to get to 9, I've got to multiply the numerator and denominator by 4, so plus 4P squared equals 1. Now, to remove the denominator, is divide on this side. So when I move it over here, it becomes multiply. So I end up with just changing the positions. 4P squared plus 9Q squared equals 1 times 36, or 36, which is what we were required to prove. Fantastic. So hit pause, copy the example down. When you're ready, hit play again, and I've got a couple of questions for you to attempt. Okay, so you're looking at exercise 10C. Because we've got new information, new identities, I would suggest that doing most of question 1 would be useful, and then 2 and 3, well, most of question 1. And then when you turn over, you could stick to the left hand side then of 4 and 5, and 6 maybe just do A and C. Okay, and then carry on. 10, just do the left hand side. 11 and 12, very typical exam questions, so be very worthwhile doing. Good.